For the final problem of Chapter 1 in the Dagprunar textbook, what we have is a simple MM1 problem where we have people coming in at random times to a shop, for example, a bank in this case. They're going to see if there's someone in front of them in line. In that case, they will have a waiting time W, and then they will be served. So that will be the service time I, and A sub I will be the interval between one person coming and another person coming. So to solve for this, what we're going to first do is prove that for each wait time we have a maximum time of 0, or if this number on the right is positive, it's the wait time of the previous person minus the time between the two people arriving and the service time of the person that's in front of them if they're being served at the time that the new customer is waiting. And to do this, we'll run some simulations just to prove that with it we're able to have a realistic model that shows numbers that are all positive and therefore have wait times from 0 up to any certain amount. And to begin, we'll have an arrival rate lambda, which we'll set as 1, and our service rate mu, which we'll also set as 1, and that will give us the different wait times from 1 to n, given a certain initial wait time and of course our values of 1 and 1. So our initial wait time, what we have set up is 5 here, so the person first coming into line notices that someone in front of them is being served, and it takes 5 periods of time until that first person can go up and begin their service time. And running this, we can see two different models, one with the restriction and one without. And in some cases, we can see that with the restriction, it's going down to 0 but never going past it. But for a realistic model, we definitely need that so that we don't have negative wait time, which in all reality is impossible. In this case, it didn't show any wait times below 0, which there is a chance of that, but in the case that the same numbers would be run without the restriction for this second figure, it would probably be going beneath 0, which would not be physically possible. And now moving on to part C. We will be looking at some different plots of W and just providing some estimates on the expectation and seeing what happens as the mu and lambda are changing, both our inner arrival time average as well as our average service time. And we'll look at some of those plots. Now here we can see the wait times are constantly going up for each of the models as you saw them being generated. Here with lambda and mu both equaling 3, and we can see that as mu remains large and lambda is decreasing, we have an increased waiting time, since that time between arrivals is decreasing. And we can see that in each of them going down, and the least amount of time that we have for waiting is when our lambda equals 3 and our mu equals 1, when we're simply doing a 3 by 3 to see in comparison which has the shortest wait times. And of course we can see the numbers slowly increasing across the charts as we're going. And that's basically how we looked at the MM1 inter-arrival time and service times for just a standard line with a single server. See you next time.